Hello everybody, welcome to the Henstitute. On this one, I'm going to take a look at 71. 71 is this eagle problem. An eagle is flying horizontally at 6 meters per second with a fish in its claws. It accidentally drops the fish and it wants to know how much time has passed before the fish's speed doubles and then how much additional time for it to double again. So when you look at this, the most common idea is we know that we're probably using some kind of equation like this, that VF equals VI plus AT, or in terms of falling, we know that it's VFY equals VIY minus GT. The hard part about this is people want to use that 6 meters per second as like a VIY and then the doubling it, so 12 is like a VF, but that's wrong. Neither one of those is actually VFY or VIY. They are VIs and VFs, but they're in the wrong direction. We can't use this without putting little subscripts on here. So I don't use this, I use this equation, or we use the idea that Vx is x over t, and in that case, to find time, I would need to know horizontal displacement. So I highly doubt if we're using that. We're going to end up using this equation. So what I need to do is let's get to an actual setup for this. So here is my absolutely horrible drawing of an eagle. So this is supposed to be my eagle. It actually looks more like a goose, but it's got our fish, and the idea is it's moving horizontally at 6 meters per second. Now I would point out a key idea here is that its initial vertical velocity is actually 0 because it's only going horizontally. After a period of time, once the fish wiggles out and it falls, it's going to fall through this nice little parabolic path, and so at some point later the fish is going to be somewhere down here. And the idea is the fish is going to be heading in this general direction. And this is where that speed doubling comes in. This is what is going to be 12 meters per second. I would argue that that is just plain VF. It's not VFY, it's not VFX, it's just VF. It's actually made up of two other velocities. It's made up of how fast this thing is going horizontally. So it's moving horizontally at some velocity, but that is still going to be 6 meters per second. So the idea is it still continually moves at 6 meters per second. Then it also has a vertical component to it. So it's going to pick up some vertical velocity here. It's going to be heading downward. That is VFY. And if I take that green and put it over here instead to make a triangle out of it, VFY would go right here. This is a nice little right triangle. So what I can use is I can use this blue, green, black triangle to actually find VFY. That's the Pythagorean theorem stuff that we did before. And it will allow me to actually find that if I plug it in to VF squared equals VX squared plus VFY squared. I know these numbers. VF is 12. Vx is 6. We don't know what VFY is. So I plug it in here, I figure out what VFY is. So many meters per second. Now it's technically going to be negative. It's going to be going downward. We don't see that as much from this equation, but we can see it from the picture. Now I can actually incorporate to find time by using this equation, that VFY equals VIY minus GT. If I want to rearrange that and solve it for time, it's going to look like this. I would subtract the VIY over to the other side and divide by negative g. So time would be VFY minus VIY all over negative g. So this is how we're going to find our time, but we have to find our VFY first using this. That's how we do part A. Part B is basically the same, except that now our VF is going to be doubling again. So it's going to go from 12 to 24. Using 24 in this equation up here, we can solve for another VFY. And this VFY would be after that. If you do that Then when you come back over here, since it wants additional time, your new VI would actually be the VF that you found in this part A. That's going to be the VIY, and then you'd have to use the new VFY as the true final to find the time. Or you come back to using 0, but then that's going to be the total time you'd have to subtract off. I think it's easier if you just turn this velocity over here into your initial velocity. Should be good. I hope this helps with problem number 71, and you enjoyed this edition of the Henstitute.